You ever wonder why some tech platforms can scale to billions of users, just seemingly without a hitch, while others just crumble under their own success? Well, today we're going to dive into those hidden battles, the ones fought in server rooms that really separate the code that just works for a little while from the code that truly, truly endures.
You know, this is just one of those hard truths in technology. It doesn't matter how brilliant or modern your code is today, tomorrow it becomes the foundation or maybe the prison for whatever has to come next. So the real question isn't if your code becomes legacy, but what kind of legacy it's going to be.
And let me tell you, sometimes that legacy shows up in some very public and very memorable ways. It's that moment when all the digital seams start to tear apart and, yeah, everyone is watching.
The fail whale. For years, this was pretty much Twitter's unwanted mascot, right? It would pop up during elections, huge news events, celebrity meltdowns, basically the exact moments the service was needed most. I mean, it was this perfect, almost poetic symbol of a platform just breaking under the weight of its own incredible growth.
It's so easy to just point fingers and blame the engineers, but the real story is always, always more complex than that. It's not about one single bug or some clumsy mistake. No, the answer lies in something much deeper, a force that just builds up silently, over time. And that force has a name. It's one of the most powerful and, honestly, most misunderstood concepts in all of tech. It's this kind of debt that never, ever shows up on a balance sheet, but it can absolutely bankrupt a company.
Yeah, we call it technical debt. And the best way to think about it is just like financial debt. You take a shortcut now so you can move faster, but you know you have to pay it back later, and you got to pay it with interest. It isn't always a mistake. Sometimes it's a strategic choice. But if you never pay it down, well, that interest just keeps compounding.
And wow, that interest is brutal. All of a sudden, adding a simple new feature takes months instead of weeks. Trying to apply a critical security patch becomes a total nightmare. In innovation, it just grinds to a halt because your teams are spending all their time just fighting the architecture of the past. It's exactly what Twitter learned the hard way. So how do successful companies actually manage this? Well, let's take a look at Shopify. Instead of waiting around for their own fail whale moment, they decided to get way out in front of the problem. They treated their technical debt not as some engineering chore, but as a core business priority. Shopify's plan for upgrading their massive system was just incredibly methodical. Instead of stopping everything for a huge, risky rewrite, they used what they called a dual-track system. So one team could keep building new features for customers, while another team worked in parallel on the big upgrade underneath. They moved things over piece by piece to make sure it was stable, and this is the crucial part, they tied every single part of that upgrade to clear business value. And that right there, that's the big lesson, isn't it? Your code, your tech infrastructure, it's not just a line item on an expense report. It's the engine of the business. Investing in its health isn't some luxury. It's an absolute strategic necessity if you want long-term growth. Okay, so Shopify's proactive approach is one way to do it, but it's not the only way. Now let's jump over to GitHub. They were facing a really similar scaling crisis with their database, and they chose a path of just incredible patience, inspired by this fascinating metaphor from the natural world. They called it the strangler fig strategy. I'm serious. Instead of just ripping out the old system, they carefully built the new one around it. So new features would use the new system, while the old one just kept on running in the background. They moved data over bit by bit with constant checks. It was slow, it was careful, and it was almost completely invisible to the millions of developers who depend on GitHub every day. So you see the difference here, right? It's just a night and day comparison. On one side, you've got GitHub's calm, planned evolution where reliability was everything. And on the other, you've got Twitter's crisis-driven recovery, a frantic, public rebuild under just immense pressure. In the end, both companies succeeded, but wow, they took vastly different roads to get there. When you put these stories together, you start to see a pattern emerge, a kind of blueprint for not just writing code, but for building technology that's actually designed to last, to adapt, and to scale gracefully. So let's circle back to where we started, Twitter. After all that painful public struggle, what was the result of finally paying down all that technical debt? Well, it kind of comes down to this one number.
500 million tweets a day. The platform that once crashed during the World Cup was now the place where the world happened in real time. This wasn't just a tech fix, it was a total transformation from an unreliable toy into a piece of critical global infrastructure. That's the payoff.
So what can we take away from all this? Well, these 5 principles just keep showing up.
1. Treat your tech debt like a business problem, not just an engineering one. 2. Choose evolution over revolution. Gradual change is almost always better. 3. Connect every technical change to real customer value. 4. Build your systems expecting them to fail so they're resilient. And 5. Above all else, protect your users' experience during any big transition.
At the end of the day, these stories aren't just about databases or coding languages. They're about choices, about priorities, and about the long-term consequences of the decisions we make right now today.
Because whether you're building a simple little app or a massive global platform, all software eventually becomes legacy code. It becomes the solid foundation for tomorrow's big idea, or the prison that prevents it from ever happening. So the question we're left with is a simple one, but a profound one. What story will the code you write today tell tomorrow?